Hi, my name's Olivia Vorius, and it is 7/8/25. This is my flow chart for macromolecule movement and synthesis. Okay, see here. All right, so I started with testosterone. Testosterone is a lipid, and behind the word testosterone, you can see the image of Leydig cells, and this is something that will come into play right here. Okay, so we start with the pituitary gland. The pituitary gland secretes follicle-stimulating hormone and luteinizing hormone, telling the Leydig cells that I was just mentioning of the testes to produce testosterone, and cholesterol is metabolized. So free cholesterol is transported to the mitochondria of the cell, where it is metabolized into what is called pregnenolone. Moving on, pregnenolone is metabolized in the smooth endoplasmic reticulum by several enzymes. This enzymatic process results in the synthesis of testosterone. Once testosterone is synthesized, it's secreted from the Leydig cells. So testosterone's final destination. Testosterone can then do a couple of things. It can either enter the bloodstream as free testosterone, it can bind to proteins, or it has the option to go to target organs and bind to their androgen receptors. Okay. Next, we have insulin. Okay, so as you can see behind the word insulin, we have proinsulin and insulin molecules. All right, so to create insulin, we have to start with something that's called proinsulin. It's a precursor that's a signal protein that is cleaved and transported to the rough endoplasmic reticulum. Then the rough endoplasmic reticulum rapidly folds the proinsulin protein. The Golgi apparatus packages the proinsulin into secretory granules, where it is then converted into insulin. And then just to touch base on why we would need insulin, high glucose levels in the blood call for the secretion of insulin in order to lower blood glucose levels. So, the beta cells of the islets of Langerhans of the pancreas secrete the insulin, where it then binds to cell receptors, telling them to absorb the glucose, thus decreasing overall blood glucose. All right. Last, we have actin, and I have an image up here of an actin filament. But individually, we have actin synthesis and movement. So actin is a polymer that has a few forms such as G or F actin. The way that actin is synthesized is utilizing the ribosomes. So ribosomes located in the cytoplasm encode mRNA to assemble the amino acids that make up actin. Actin's destination. It forms filaments beneath the cell membrane to support the cell. Actin helps the movement, cleavage, and phagocytosis functions of the cell.